Okay, this is the absolute value equation worksheet. We're trying to solve an absolute value equation. Let's take a look and notice this, that if we look at this concept from first principles, I'm going to bring in a real number line here. And what we're looking at is we're trying to find values of x that an absolute value equals 8. Now what this means is we got two numbers that are 8 units away from the origin. One number is going to be positive 8, which is over here to the right, so where the positive numbers live. And the other number is negative 8, an equal distance in the opposite direction, and it's where the negative numbers live. So if we take a look at this in some detail, that the distance each one of these numbers live from the origin is about 8 units. And that's the absolute value here of 8. So notice positive 8 in absolute value is 8. Negative 8 in absolute value is 8, because both of these numbers live 8 units away from the origin. And that's really the meaning of absolute value, how far a number is from the origin. So our solution is going to look like the following. We say x is 8 or x is minus 8. These are our two solutions. If we write this in set notation, we're going to see this set notation and our two numbers listed with a comma between. The solution set is 8 and negative 8. So these two numbers are 8 units away from the origin. And this is number 1. Number 3 is the same type of question. We have the absolute value of x is 4. We could look at it and approach it the same way, meaning we're going to determine what numbers are simply 4 units away from the origin. And we notice here that there's actually two numbers. So let's get our graph. And let's take a look. The number 4 over here to the right, the number negative 4 on the opposite direction to the left is 0, where all the negative numbers live. Positive 4, negative 4. If we notice, both of these numbers are 4 units away from the origin. That is, the absolute value of 4 is positive 4. The absolute value of negative 4 is also positive 4. Okay. These two numbers are 4 units away from the origin. And we don't really care about the direction, we just care that they're 4 units away. So these two numbers we often write as our solutions, that x is negative 4 or x is positive 4, are two solutions. In set notation, we have negative 4, comma, positive 4, and we're done. Notice something we could do though. What's going to be a good tool for us to solve the same question here, just so we know, is we're going to use the following relationship. If I bring out my t, which is just simply separating my paper into two separate regions, a left region and a right region, we can simply use this format and say the absolute value of x is going to be either positive 4 or the absolute value of x is negative 4. And that's because if I have the absolute value of any number equals a positive number, if we have this, okay, let's write it again. If the absolute value of some number or even expression is positive, then what we know is that number is either P, or that number or expression is opposite P. This is where this T comes from. This here is what we use to solve absolute value equations. I'm going to note, though, that let's recall from lecture that if the absolute value of any number is 0, then that number has to be 0. Because the only way I can get the absolute value of a number to be 0 is if the number is 0. So this is something that's important for us to remember. What's also important for us to remember is the following. That in question number 5 on the homework, we have the absolute value of x is actually -5. Let's stop and think for a second here. We need to know how far a number is from 0. Meaning, we may think that 5 and -5, like the prior examples or the prior problems, are both 5 units away, or I should say -5 units away from the origin. Now, let's notice something here. If I look at the graph, we'll go through every detail. What we've been doing here is we've simply been saying the following. 5 and the other direction, -5, that these two numbers are actually 5 units away from the origin. Now that's +5 units. So that our solution was -5 and +5. However, take a look at this here. You have the absolute value equal to a negative. Now, this is saying what numbers are -5 units away from the origin. Now, the distance that a number is away from the origin is never negative. What I'm saying here is that this never happens. So from lecture, we notice that this never happens, and take a look. The absolute value, right, of +5 is never -5. And the absolute value of a -5 is also never -5. There are no numbers that are -5 units away from the origin. There are numbers that are +5 units away from the origin, but never -5 units away from the origin. So what we say here, that there is simply no solution, if you guys recall. The solution set is empty, and what that looks like in some ways is simply this. You have your set bracket notation, and if you notice, it is empty. There is nothing inside this bracket. This is what we're describing as the empty set. So moral of the story is, if you ever have the absolute value of anything and it's negative, there's no solution. That's different than what you have here. What you have here, the important thing to remember is that P has to be positive. Okay? You have a positive P value. And when it's 0, we say the absolute value of 0 is 0, or the number here is 0. So we're going to use these two facts, these two relationships, to solve all our homework questions today, as we did in lecture. So let's take a look at number 7. Number 7 is minus the absolute value of x is -3. Now let's be careful. What we learned was the negative sign here that you guys see right here is outside of the absolute value. What that means is this is -1 times the absolute value of x, and that's going to be equal to -3. So the key here for these problems is to solve for the absolute value of x. And how we do that is by dividing both sides by -1. And our -1 cancels. We get absolute value of x is a negative 3 divided by a negative 1, which is positive 3. When we use our format, we discover that x is 3 or x is minus 3 are two solutions. Solution set notation, 3, comma, negative 3. We're done. Number 9, minus the absolute value of x is 2. We're in the same scenario where we're going to notice that the negative sign is outside our absolute value. So we write this as negative 1 times the absolute value of x is positive 2. Going to divide both sides by negative 1 to solve for the absolute value. Notice negative 1 cancels. We just solve for the absolute value. We get the absolute value of x being positive 2 divided by a negative 1, which is negative 2. The absolute value of a number is never negative 2. This never happens. Meaning the absolute value is never negative. We say there's no solution. We can use the empty set symbol, which is symbolized this way in terms of a picture of a set. The set is empty. No solution. Number 11, the absolute value of 2x is positive 4. We're going to use our format. I'm going to write down 2x is positive 4 in one case, or 2x is opposite, which is negative 4 in the other case. We have two linear equations to solve, and we divide both sides here by 2 for each equation to solve for x. Get rid of your 2's, and you get x is 4 divided by 2, which is positive 2. 2's cancel. X is negative 4 divided by positive 2, which is negative 2. Your solutions are positive 2 and negative 2. You're done. Number 13. The absolute value of 5x equals positive 15. The number is positive, so we can use our format and say that in one case the 5x is positive 15. Notice this. This 5x in one case is positive 15, and in the other case you can say or 5x is opposite or negative 15. You know, we're looking at the two situations. And that's because if we really take a look, we're replacing 5x with, in one case, positive 15, and the other, negative 15. Because in absolute value, both of these are actually 15. Excuse me. Divide both sides by 5 for each equation. Cancellation on the left. I get x is 15 divided by 5, which is positive 3. And I get x is equal to negative 15 divided by 5, which is negative 3. I have two solutions here. This is number 13. Number 15, we got the absolute value of 4x here is a negative number, negative 24. Once again, we say this can never happen. Okay, there is no real solution. No real solution. Your solution set is empty. We got the empty set, number 15. Number 17. we have minus absolute value of 2x is negative 24. Now be careful. We have two negatives here. Okay? So on the left side, this is really negative 1 times the absolute value of 2x. And on the right side, I have a negative 24. Now that negative sign on the left side is outside my absolute value sign. So what I can do here is divide both sides by negative 1. I get my cancellation, and you end up with the absolute value of 2x being negative divided by a negative, which is positive 24. Now this does happen, okay? The absolute value is positive. So 2x is 24. So here's what we're essentially saying. In one case, that 2x is positive 24. In the other case, it's negative 24. We use our t table here, or this device that we split our paper in two pieces, is we're saying 2x is positive 24 in one case, or 2x is negative what? 24, okay? Divide both sides now by 2. And the 2 goes away on the left here. We end up with a x equals 24 divided by 2, which is 12. X equals negative 24 divided by 2, which is negative 12. So our solution set is 12 comma negative 12, and you're done. This is number 17. Number 19, we have negative absolute value 8x is negative 6. Now let's not be so quick to conclude that there's no solution. Even though we have the absolute value equal to a negative, there's a negative in front or outside of that absolute value sign. So this really means negative 1 times the absolute value of 8x is negative 6. So again, we're going to solve for the absolute value by dividing both sides here by negative 1, so we get cancellation. We'll have the absolute value of 8x now be negative divided by a negative, which is positive. So we're going to use our format. Now let's note what this really means again is 8x is 6, and it's positive 6. So 8x is going to be positive 6, or 8x is going to be negative 6. Let's use our t. 8x is positive 6, or your 8x is negative 6. We're going to divide both sides here by 8, since we're solving two linear equations for both equations here. And you're going to get some cancellation with the 8. We get x equals 6/8, or x is minus 6/8. We got to simplify this fraction. Notice 6 is written as 2 times 3, and 8 is 2 times 2 times 2. So my 2 and my 3 will cancel, or so, I'm sorry, my 2 and my 2 cancels, then we're left with just 3 over 4. And that's the answer we get for both 3/4 or negative 3/4. These are my solutions. So solution set will be 3/4 comma negative 3/4, and we're done. Number 19. The absolute value of x minus 4 is the value of 7. This means x minus 4 is positive 7, so let's notate this, or x minus 4 is negative 7. Notice the absolute value of both of these numbers is positive 7. So let's use our format. X minus 4 is positive 7. Or x minus 4 is opposite. It's negative 7. We have a linear equation to solve, actually two. We're going to add 4 to both sides. We're going to end up with x is 11 or x is negative 3. These are our values. And we're done. Number 23, the absolute value of x plus 7 is 19. X plus 7 is positive 19, so we have two scenarios again. My x plus 7 is positive 19, or my x plus 7 is negative 19, because the absolute value of both of these is a 19. And here we go. X plus 7 is positive 19, or x plus 7 is negative 19. I'm going to subtract 7 from both sides, and we get x is 19 minus 7, which is 12, or x is negative 26. These are the values of x that satisfy the absolute value equation. And we're done. I'm just going to point out a few details here. That if x is 12, or if x is negative 26, that notice that 12 plus 7 is going to be the 19, and negative 26 plus 7 is actually negative 19. So these values that we're looking at here for x are solutions to that absolute value equation. And that's all. Number 25. The absolute value of 3x plus 2 is 12. And again, we notice that 3x plus 2 is positive 12. So in one case, my 3x plus 2 will be positive 12. In the other case, it's negative 12, because the absolute value of both of these numbers is 12. Let's use our format. 3x plus 2 is 12, or 3x plus 2, let's write this clearer, is negative 12. We have two linear equations to solve. We're going to subtract 2 here from both sides for both equations. We get 3x is 10, or 3x is negative 14. Divide both sides here of both of your equations by positive 3. We end up with here x being 10/3, or we end up with x being negative 14/3. Two solutions here. Both of these values of x, when I plug in my absolute value equation, will give me a true statement. And we're done. Number 27. The absolute value of 5x plus 7 is 12. 5x plus 7 is positive 12. Okay, so notice again, either 5x plus 7 is positive 12, or 5x plus 7 is negative 12, because the absolute value of both of these numbers is positive 12. 5x plus 7 is positive 12. 5x plus 7 is negative 12. Two equations we have to solve. Subtract 7 from both sides for both equations. We end up with 5x is 12 minus 7 is 5. 5x is negative 19. Divide both equations by 5. X is the value of 1, or x is the value of negative 19/5. These are my solutions. Number 29. Negative absolute value, 5x plus 2, is negative 12. Notice again, the negative is outside, and I have a negative 12. So that negative outside my absolute value side means negative 1 times absolute value 5x plus 2, which is negative 12. We're going to divide both sides by negative 1, and I cancel. I get the absolute value 5x plus 2 is 12, because negative 12 divided by negative 1 is positive 12. We see that 5x plus 2 again is a positive number, so in one case it's positive 12, in the other case it's negative 12, because the absolute value of both of these numbers is positive 12. So I have 5x plus 2 is 12, or 5x plus 2 is minus 12. Subtract 2, subtract 2. You have 5x will be 10, and 5x will be negative 14. Divide both sides here of your equations for both by 5, so you get cancellation of that 5. X is going to be 10 divided by 5 is 2. So in one case x is 2, and negative 14/5 cannot be reduced. So my solution is 2 comma negative 14/5. And we're done. Number 31, 2 times the absolute value of 6, x minus 6, is 24. Now notice this is 2 times my absolute value, so I'm going to divide both sides by 2. So I get cancellation, and I get the absolute value of x minus 6 now becomes 24 divided by 2, which is 12. Okay. Now notice x minus 6 is positive 12. So again, x minus 6 is positive 12, or it is negative 12. Because the absolute value of both positive 12 and negative 12 is both positive 12. So let's solve each linear equation. We add 6 to both sides here for both equations. And we'll end up with x is 18 for one, or x is negative 6 for the other, because negative 12 plus 6 is negative 6. My solutions are positive 18, negative 6. Notice something again. Just to emphasize the point that in one case x is positive 18, and in the other case x is a negative 6. So 18 minus 6 is 12, and negative 6 minus 6 is negative 12. So in absolute value, they're both positive 12. This is what it means to have a solution. Number 33, we have negative 3, absolute value of x minus 6, is negative 24. Notice I'm going to have to solve for the absolute value. Okay, so in order to do so, I divide both sides by negative 3. Since this negative 3 outside is being multiplied to my absolute value, I'll obtain the absolute value of x minus 6 equals a negative divided by a negative is a positive. So we solved for the absolute value. We're now going to apply the fact that I have an absolute value equal to a positive number. I have x minus 6 in one case is positive 8, and in the other case is negative 8, because the absolute value of both of these numbers is positive 8. So I have x minus 6 is 8, or x minus 6 is negative 8. Add 6 to both sides, add 6. We end up with x being 14, or x being negative 2. So these answers here for x, again, to go back and make clear, I know x minus 6 is 8 and negative 8, but if I let x be 14, if I let x be negative 2, notice this, that 14 minus 6 is the 8, and negative 2 minus 6 is the negative 8. So both of these numbers are solutions. Number 35, we have 1 minus x in absolute value is 4. Notice this means 1 minus x is 4. In one case, it's positive 4. The other case is negative 4. Because the absolute value of both of these numbers is a positive 4. If we use our format, we have 1 minus x is positive 4, or 1 minus x is negative 4. Subtract 1 from both sides for both equations, and you obtain negative x is 3, or negative x is negative 5. Notice here that this will be negative 1 times x for both. So I divide both sides by a negative 1. Cancel, we get x is positive over negative is a negative, and x is going to be 5. These are two solutions. Number 37. The absolute value of 1 minus 2x is 15. So notice, in one case, 1 minus 2x will be positive 15. And the other case, 1 minus 2x is negative 15, because the absolute value of both of these numbers is positive 15. 1 minus 2x is positive 15. 1 minus 2x is negative 15. Let's solve these equations. I'm going to subtract 1 from both sides for both equations, and we're going to end up with negative 2x is 15 minus 1, which is 14. Negative 2x is a negative 16. Divide both sides by negative 2. Gone, 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 and gone. We obtain x equal to a positive over a negative. X equal to, this is going to be 8, 2 negatives here. Our solution is negative 7, comma, positive 8. This is our solution set. Number 39, the absolute value, 4 minus 3x is 19. 4 minus 3x is a positive 19. So in one case, 4 minus 3x is that positive 19. And the other case, it's a negative 19. Because the absolute value of both of these numbers is positive 19. Let's draw our format here. 4 minus 3x is positive 19, or 4 minus 3x is a negative 19. Let's solve our equations here. Subtract 4 from both equations. I get negative 3x is 15. Negative 3x is negative 23. Let's divide both sides now by negative 3. Cancel and cancel. For both of these, we're left with our x. X is a positive over a negative is a negative. X is a negative divided by a negative is a positive. Notice 23 over 3, we have 2 primes, and they're not the same prime, so there's no cancellation. Final answer is negative 5, comma, 23 divided by 3. $41. 2 times the absolute value of x plus 3 is 9. We're going to need to solve for this absolute value. We do that by subtracting 3 from both sides. And you get 2 times the absolute value of x is 9 minus 3, which is 6. We haven't solved for the absolute value yet. We're going to have to divide both sides by 2, so I get cancellation by 2 on the left here. And now we have the absolute value of x equals 6 divided by 2, which is 3. We just solved for the absolute value of x. Now we could do two things. We can notice that x is positive 3 again, right? Or x is negative 3. So we could just write this down as x is positive 3 or x is negative 3, because both of these answers or values give the absolute value a positive 3. So 3 comma negative 3 in solution set notation to 41. $43 is 2 times the absolute value of x minus 3 plus 1 is 9. We need to solve for this absolute value. So we're going to subtract 1 from both sides. We end up with 2 times the absolute value of x minus 3 is 9 minus 1, which is 8. We haven't solved for the absolute value yet. Divide both sides by this 2. Your 2's cancel, and you get the absolute value, x minus 3, is 8 divided by 2, which is 4. Now, we have a solution here, and that is simply the absolute value of x minus 3 in one case is positive 4, and in the other case it's negative 4. So I have x minus 3 is positive 4 in one case, and the other case x minus 3 is negative 4. We're going to add 3 to both sides here. We get x to be 7 or x to be negative 1. 7 comma negative 1 in solution set. And we are done. It's 43. I'm going to look at 45. 2 absolute value x minus 5 plus 8 is positive 2. We're going to have to solve for the absolute value. You subtract your 8 and you get 2 absolute value. X minus 5 is negative 6. You're going to divide both sides here by positive 2. So they get cancellation. We now get absolute value x minus 5 is negative 3. Again, let's point out to you that the absolute value is never negative. This never happens. There's no real solution, or we say we represent this in set notation with the empty set. Number 47. 3 times the absolute value of x plus 5 plus 10 is 16. You're going to subtract your 10 from both sides. And we're going to end up with 3 times the absolute value. X plus 5 is 6. We're going to divide both sides here by 3 to solve for my absolute value. And I get cancellation on the left. We get the absolute value, x plus 5 is 6 divided by 3, which is 2. X plus 5 in one case is positive 2, and x plus 5 in another case is negative 2. So here's what this looks like. X plus 5 is positive 2. Or x plus 5 is negative 2. And subtract 5 from both sides. You end up with x is negative 3, or x is negative 7. This is your solution. Negative 3, negative 7 for 47. (49) I have minus 3 absolute value x plus 4 plus 10 is negative 17. We need to solve for the absolute value. So we have negative 3 absolute value x plus 4 is negative 27. Divide both sides by this negative 3, which is multiplied to my absolute value. I get cancellation on the left. I now end up with x plus 4 in absolute value is positive 9. Now again, in one case x plus 4 is positive 9, and in the other case it is negative 9. So the absolute value of both positive 9 and negative 9 is positive 9. I'm going to write this as x plus 4 is positive 9. X plus 4 is negative 9. Solve this for x. Subtract 4 from both sides, and you end up with x being 9 minus 4, which is 5. X being negative 9 minus 4, which is negative 13. So two solutions, 5 comma 13. That 13 is negative. Number 51, negative 2, absolute value, x plus 7 plus my 10 is negative 18. Looks like this is 51. We need to solve for the absolute value. Subtract 10 from both sides. Negative 2, absolute value, x plus 7 is negative 28. Divide both sides by my negative 2. I get cancellation here. I end up with the absolute value of x plus 7 is 14. X plus 7 is positive 14 in one case. X plus 7 is negative 14 in the other case, because the absolute value of both of these numbers is positive 14. X plus 7 is positive 14, or x plus 7 is the negative 14. Let's solve by subtracting 7 from both sides here. We end up with x being 14 minus 7, which is 7, or x is negative 14 minus 7, which is negative 21. So 7 comma negative 21 is our solution. Number 53. Negative 6 times absolute value, 3x minus 4 plus 10 is negative 14. Subtract my 10 and I get negative 6. Absolute value, 3x minus 4 is negative 24. Solving for the absolute value, I have to divide both sides by negative 6. And I get here absolute value 3x minus 4 becomes negative over negative is a positive. 3x minus 4 in one case is positive 4, and in the other case is negative 4, because the absolute value of both of these numbers is positive 4. So 3x minus 4 is 4. 3x minus 4 is negative 4. Let's solve each equation. We can add 4. Three x will be 8. 3x will be 0. Divide by 3 for both sides, for both equations. You end up with x being 8 over 3, or x being 0. These are my two solutions for number 53. This is 55. We have negative 7, absolute value, 3x minus 4, minus 10 is negative 17. I'm going to solve for the absolute value. We're going to add 10 to both sides. We get negative 7 times the absolute value, 3x minus 4, will be negative 7. I'm going to divide both sides by the negative 7. So I get cancellation, because that negative 7 is being multiplied to the absolute value. So I get the absolute value of 3x minus 4 is positive 1. We have solved for the absolute value. And we can notice now that the 3x minus 4 is a positive 1, and this happens. That means in one case it's positive 1, and in the other case that 3x minus 4 is negative 1, because the absolute value of both of these numbers is positive 1. 3x minus 4 is positive 1. 3x minus 4 is negative 1. Add 4 to both sides. We end up with 3x is 5, or 3x is 3. Divide both sides by your 3. Get cancellation on the left here. You're going to have x is 5/3, or x is 1. These are our solutions. $57. 4 times the absolute value, 2x minus 5, minus 10 is negative 24. We need to solve for the absolute value. So we're going to add 10 to both sides here. 4 times the absolute value of 2x minus 5 will be negative 14. This 4 is multiplied to my absolute value. So I'm going to have to divide both sides by 4. So we get cancellation here. The absolute value of 2x minus 5 then becomes negative 14/4. Now 14/4 can be reduced. This is 7 times 2 if we write this as the product of its prime factors. 7 times 2 and then 2 times 2, where our 2's cancel. We're going to have the following. The absolute value of 2x minus 5 is actually negative 7/2. Now let's pay attention to this detail. The absolute value is never negative. This never happens. There's no real solution. We simply say the solution set is empty. Number 59, we have the absolute value of x minus 4 over 3 is a positive 12. This does happen. This means that the fraction here of x minus 4 over 3 is 12 in one case. The other case, it's negative 12 because the absolute value of both of these numbers is 12. X minus 4 over 3 is positive 12. X minus 4 over 3 is negative 12. And this is OR. So we're going to solve both of these equations by multiplying by 3 to both sides. We get cancellation here. Multiply by 3 to both sides. Cancellation, cancellation. We end up with x minus 4 on the left is 36 because that's 12 times 3. X minus 4 on the left is negative 36 because that's negative 12 times 3. We're going to add now 4 to both sides. X is 40, or x is negative what? 32. These are my solutions. 40 and negative 32. Number 61. The absolute value of x plus 4 over 2 is 2/5. This does happen. The fraction is equal to a positive number. That 2/5 is positive. So in one case, the fraction is a positive 2/5. The other case, the fraction is a negative 2/5 because both of these numbers in absolute value are positive. Positive 2/5. So I have an x plus 4 over 2 is 2/5. I have an x plus 4 over 2 is a negative 2/5. We're going to perform a procedure since we have here what's called proportions, equal ratios, known as cross multiply. Now pay attention to this here. We're going to multiply diagonals. Cross multiplication. Notice what we get. We'll get 5 times x plus 4 will become 2 times 2. What's happening here is we're going to keep here this x plus 4 on the left on top, and we're going to multiply it by this 5 that's in the denominator of the second fraction. And then we're going to keep the 2 on the right and multiply it by the 2 that's in the denominator here. We're going to do this for both of our proportions. So we'll have 5 here again times the x plus 4 will be a negative 2 times positive 2 because we have a negative value there. Let's make that clear. There's a negative 2 here. And now we're going to solve each equation, but we have to get rid of the parentheses by the distributive property. So 5 times x is 5x, and then 5 times a positive 4 is a positive 20, and this will equal a positive 4. 5x, again, plus 20 by the distributive property. In this case, or the second case, it's negative 2 times positive 2, which gives you that negative 4. Two linear equations. Subtract 20. We'll end up with 5x as negative 16 and a 5x with a negative 24. Divide both sides by 5. Cancellation in left and right. We get x is negative 16/5, or x is a negative 24/5. Both of these fractions are reduced. Number 63. The absolute value, x minus 5 over 2 plus 1 is 5/3. Let's subtract 1 from both sides because we have to solve for our absolute value. When you get the absolute value of x minus 5 over 2 will become 5/3 minus 1. Now this 1 here can be written as a fraction, and we can write this as 3 over 3. In other words, it's like fraction with that 5/3. They have the same denominator. So now I have the absolute value of x minus 5 over 2 is going to be 5 minus 3, which is 2, and this is over 3. Now again, this happens. What this means is the fraction x minus 5 over 2 in one case is 2/3, and in the other case is a negative 2/3. So we got 2/3, I got a negative 2/3. Both of them in absolute value is positive 2/3. X minus 5 over 2 is a positive 2/3. X minus 5 over 2 will be a negative 2/3. Again, we have proportions here, and we're going to cross multiply when we solve these two proportions. What you're going to get now is 3 times the x minus 5 will be 2 times 2. You'll get 3 times the x minus 5 will be negative 2 times 2. Now notice here, we're going to get rid of the parentheses by distributing that 3. 3x minus 15 will be 4, or 3x minus 15 will be a negative 4. 3x minus 15 is 4. 3x minus 15 is negative 4. We're going to add 15. We end up with 3x will be 19. 3x will be 11. Divide both sides by this 3. We get cancellation. X is 19/3. X is 11/3. These are my solutions. Number 65. The absolute value of 3x minus 2 is the absolute value of x minus 5. As we discussed in class, what we're noticing here is two things. We got two absolute values set equally to each other. That means 3x minus 2 here in the first absolute value is 3x minus 2. In one case is the same as x minus 5. So we say 3x minus 2 is the same as x minus 5. This is the same. And in the other case, we have 3x minus 2 then is not just the same, but 3x minus 2 is opposite of x minus 5. Those are our two scenarios. That the only way we can have absolute values equal to each other if they are the same values or if they are opposites. This is what we discussed in class. We now have to solve each one of these equations. Subtract x from both sides. Here we have to distribute. So we'll get an equation. 3x minus 2 is negative x now plus 5. We're going to solve these equations. We're going to add x to both sides. We get 4x minus 2 is 5. Here we get 2x minus 2 is negative 5. Add 2 to both sides. Add 2 to both sides. We end up with 2x is a negative 3, or a 4x here is 7. Divide both sides by 2. Divide both sides by 4. We end up with x is negative 3/2, or x is positive 7/4. These are my two solutions here. 67. The absolute value of x plus 2 is the same as the absolute value of x plus 4. Now again, we have two cases. In one case, they are the same. In the other case, they are opposite. So I wrote down the same on the left and the opposite on the right. We have two equations to solve. We're going to, in the left equation, subtract x. And we end up with 2 equals 4. This is a false statement. This never happens, or I should say is not true. False statement. 2 is not the same as 4. This contributes nothing to my solution. On the right, I have x plus 2 gives me negative x minus 4 when I distribute. I'm going to add x to both sides. I end up with a 2x plus 2 is negative 4. I'm going to subtract 2 from both sides. I end up with 2x is negative 6. Divide both sides by 2. I get x will be negative 3. So the left side contributes nothing to the solution set, but the right side has a single value of negative 3. Notice what this means. If I now go back and plug in for x, negative 3, on the left I have in my absolute value negative 3 plus 2, which is negative 1. So I'm going to have the absolute value of negative 1, which is positive 1 on the left, and on the right, negative 3 plus 4 is also negative 1, or sorry, is positive 1. So what we're seeing here when we plug these values in is on the left side, my number is negative 1, and on the right side, my number is positive 1. So that the absolute value of both of these numbers are the same. They're both positive 1. The last question. Number 69. The absolute value of x minus 5 is the absolute value of 5 minus x. Again, two absolute values. And they are equal to each other. So this means that we have two situations again. Either they are the same, I mean x minus 5 is the same as 5 minus x. Or they are opposites. X minus 5 is opposite 5 minus x. Distribute on the right side. So let's solve these equations here, and we notice we get plus x, and on the left I have 2x minus 5 is 5. Let's add our 5 to both sides here, and I end up with 2x equals 10. Divide both sides by 2. I get cancellation here. I have x equals 10 over 2, which is 5. This is my first equation. If I distribute for the second equation, I get negative 5 and I get positive x. So now, when I subtract x from both sides, I end up with negative 5 equal to negative 5. This here is a true statement. This means all real numbers is our solution set. We discussed this in class. So our final answer here is going to be the set of all real numbers. This is the answer for number 69.